You ever look at a mountain range or maybe feel a tiny tremor and just wonder, what incredible forces are actually at play here? Why do we have these deep oceans and soaring peaks? Why do the continents kind of look like they could all fit together? Well, the answer is this amazing story that's happening right now, deep, deep beneath our feet. Today, we are diving into the world of tectonic plates.
I mean, it feels solid, right? Like you're standing on one giant, unmoving rock. But, that feeling is one of the biggest illusions on Earth. What if I told you that the ground you're on at this very moment is just one piece of a massive, constantly shifting global puzzle? Let's go uncover our planet's biggest secret.
Okay, so to understand our totally dynamic world, we have to start with this one core idea. The surface of our planet isn't one solid piece. Oh no, it's way more dramatic than that. And getting this one secret is the key to understanding just so much about our world. I mean, everything from how mountains are born to what causes the most powerful earthquakes. The solid ground we live on, it's not solid at all. It's broken.
The scientific name for this outer shell is the lithosphere. That comes from the Greek word lithos, which means stone. And this stony sphere, this cool, rigid layer we all call home, is actually fractured into these enormous slabs of rock. A really fantastic way to picture this is with a hard-boiled egg. Just imagine you're holding one that's been lightly tapped and cracked all over. The shell itself? That's the Earth's lithosphere. All those little cracks crisscrossing the surface, those are the boundaries between the plates. And each individual piece of that broken shell, well, that's a tectonic plate. It's a simple analogy, but it's a really powerful way to picture our planet.
Right, but here's the thing. Not all of these plates are created equal. They're all drifting and floating on the hotter, softer layer below them, but they come in two main flavors. And understanding the difference between them is absolutely crucial for knowing what happens when they meet.
So first up, we've got the continental plates. These things are thick, but they're made of a relatively light rock like granite. So they float high. And then you have the oceanic plates. They're much thinner, but they're made of a really dense, heavy rock called basalt, which makes them sit a lot lower.
So to make it even simpler, just think of a continental plate as a big, thick piece of styrofoam. And think of an oceanic plate as a thinner but much, much heavier brick. Just keep that image locked in your mind, styrofoam versus a brick, because it perfectly explains what happens when these two different types of plates eventually crash into each other.
Okay, so now we have this picture of giant styrofoam and brick puzzle pieces floating around. But what on earth could possibly be powerful enough to move these continent-sized slabs of solid rock?
What is this incredible engine that's driving the entire surface of our world? Well, the answer isn't on the surface. It's deep within the Earth's interior, in this vast, hot layer called the mantle. See, way down deep inside the planet, the core's intense heat warms up the rock in the mantle, making it slowly rise, kind of like hot water rising in a pot on the stove. As it gets closer to the cooler crust, it loses heat and starts to sink back down. This massive, slow-motion circular flow is called convection, and it acts like a giant planetary-scale conveyor belt, just carrying the plates along for the ride.
Now, this movement is not fast. We're talking about an average of 2.5 centimeters a year. That's about the same speed your fingernails grow. It's totally imperceptible to us, but over geological time, we're talking millions of years. This tiny, relentless movement completely rearranges the face of the planet.
And this brings us to where the real action is, the boundaries, the edges where these plates meet. These zones are where we see the most powerful and creative forces on our planet, shaping the world in three main ways.
So the first type is a convergent boundary. And just like the name says, this is where two plates are on a collision course, moving straight towards each other in a slow-motion crash of just unimaginable force.
Now what happens next depends on which plates are involved. Remember the brick and the styrofoam? When a dense oceanic plate, that's our brick, smashes into a lighter continental plate, the heavy brick sinks, or subducts, right underneath it. That process carves out deep ocean trenches and fuels volcanoes, like in the Andes. But if two continental plates, two pieces of styrofoam, collide, neither one can sink. They've got nowhere to go but up. They just crumple and fold and create these absolutely colossal mountain ranges, like the Himalayas.
The second type of boundary is divergent, which is the complete opposite. Instead of crashing together, these plates are actively pulling apart, creating a giant rift between them.
So as the plates separate, hot magma from the mantle wells up to fill that void. It then cools down, solidifies, and creates brand new crust on the ocean floor. This process is happening constantly, and it has built these enormous underwater mountain chains called mid-ocean ridges. This is literally where the Earth is building a new surface for itself.
And the third type is a transform boundary. In this scenario, the plates aren't colliding, and they're not separating. Instead, they're just grinding past one another horizontally, kind of like two giant pieces of sandpaper rubbing against each other.
But their edges are jagged and rough, so they don't slide smoothly at all. They lock up, they get stuck, and as the rest of the plates keep trying to move, immense stress just builds and builds and builds along that fault line. And then, eventually, the rock breaks and all that stored-up energy is released in a sudden, violent jolt. That is an earthquake. California's San Andreas Fault is a really famous and very active example of this.
So when you combine all three of these movements, the collisions, the separations, the grinding, and you let that happen all over the globe for billions of years, well, you get the dynamic, living, and constantly evolving planet that we know and love today. What are the actual results of this slow-motion geological dance that's been shaping our planet for eons? Well, the evidence is literally all around us. It's written into the very landscape of our world. This planetary engine has given us our highest peaks and our deepest oceans. It's what fuels the volcanoes that vent gases from the interior, which helped shape our very atmosphere. It causes the ground-shaking earthquakes that remind us of the power right beneath our feet. And maybe most profound of all, it has ferried the continents across the globe, from that ancient supercontinent of Pangaea to the world map that we recognize today. You know, there's a really powerful way to think about it. Tectonic plates are the planet's tireless construction crew. Over these immense stretches of time, they are always at work, building up, tearing down, and completely reshaping the surface of our world. It's a process that is just as fundamental to our planet as the wind and the rain.
And this all leads to a final, really awe-inspiring thought. This whole process, it isn't a story from the past. It is happening right now, as you're listening to this. The continents are still moving. So the map of our world is not final. Which leaves us with a pretty fascinating question. What's our planet going to look like in the distant future? Where will this construction crew move the continents in the next 250 million years?